In this lecture, I would like to continue the Le-Chatelier principle and the effect of temperature, pressure, concentration, and volume change on the equilibrium. So, in Le-Chatelier principle, we know that whatever the change we have to bring into the system, that change will be undo. Whatever change we want to bring into the system, that change will be undo by changing the other variables. And to maintain the equilibria, we have to change the other variables. Suppose that if we want to increase the pressure of the system, then on the same time we have to decrease the pressure, we have to decrease the temperature. So if the reaction is favorable at higher pressure, then we are trying to keep the pressure higher, but on the same time we cannot increase the temperature of the system. So as low as possible we have to keep the temperature low. It means that that reaction is favorable at high pressure and low temperature. For example, in the production of the ammonia gas by Haber's process, when nitrogen molecule reacts with three hydrogen molecules and there is a formation of the two ammonia molecules. So in this reaction, as we increase the pressure, the reaction is shifted to the forward direction, because increase in pressure means decrease in volume. In the left hand side, one nitrogen molecule get reacts with three hydrogen molecules and there is a formation of two ammonia molecules. So as we increase the pressure, the reaction is favorable to decrease the number of molecules of the product, that is volume of the product get decreases. So we cannot increase the temperature. So that reaction is favorable at high pressure and low temperature. Okay. So whatever the change we want to bring, that change will be undo and the equilibrium will be shifted to that direction. So let us see the slide belongs to the Le-Chatelier principle. Okay. So you can see here in the Le-Chatelier principle, the statement of the Le-Chatelier principle, it is already discussed by us in the previous lecture, but I would like to continue once again this. So you can see here the principle states that for a system in dynamic equilibrium, whenever there is a change of variables, it means if we want to change the temperature, if we want to change the pressure, or if we want to change the concentration, the system shall try to undo the effect. The system shall try to undo the effect of imposed restrictions. So in trying to undo the effect, there shall be change in some other variables. In trying to undo the effect, there shall be change in some other variables of the reaction to keep the equilibrium of the reaction. So this is the Le-Chatelier principle. It has been already discussed by us in the previous lecture. So effect of temperature change. Effect of temperature change. So if the temperature of the system in equilibrium is increased, if the temperature of a system in equilibrium is increased, then the equilibrium will adjust itself in the direction which absorbs the heat. Because as we increase the temperature, the heat energy will be increases. Then the equilibrium will adjust itself in the direction which absorbs the heat. Okay. On the other hand, lowering of the temperature will shift the equilibrium in the direction evolving the heat. Lowering of the temperature will shift the equilibrium in the direction evolving the heat. Okay. Thus, if the reaction is endothermic, heating the system at equilibrium cause a shift in the equilibrium to the right with the formation of more products and hence an increase in the value of the equilibrium constant. So for the endothermic reaction, As we increase the temperature, the more and more heat energy get absorbed there, and that reaction will be shifted to the right, means in the forward direction, where more and more products will be formed there. Okay, and on the same time there will be the increase in the value of the equilibrium constant. Now in case of the exothermic reaction, already we know that in the exothermic reaction heat energy is liberated, heat energy is given out, heat energy is evolved. In the exothermic reaction heat energy is liberated, so the application of the heat will cause the reaction to shift to the left. If we increase the temperature of such a system, the reaction will be takes place shifted to the left, means into the backward direction. It means more reactants will be produced at the cost of the products, and hence a decrease in the value of the equilibrium constant. Equilibrium constant becomes decreases. Okay, so in short we can say that for an endothermic reversible reaction, if the reaction is endothermic, high temperature is favorable, because for the endothermic reaction heat energy get absorbed. Okay, so high temperature is favorable. Whatever temperature we supply, that will be get absorbed by the reactant, and reactants are converted to the products. More and more product will be formed. This is for the endothermic reversible reaction. That reaction is favorable with high temperature, and the equilibrium is shifted to right, means in the forward direction. While in the exothermic reaction, we require low temperature, because already heat energy is given out. For the exothermic reaction, we require lower temperature. So exothermic reactions are favored at low temperature. So you can see this example here. Formation of ammonia molecule. Now the reaction between nitrogen and hydrogen, which produces ammonia molecule. Two ammonia molecules are produced here. So this reaction shows that there is a positive enthalpy change, indicates that the reaction is endothermic. So production of ammonia gas by Haber's process, it is a endothermic reaction. It is a endothermic reaction. So for such reaction, if we increase the temperature, so that temperature being get absorbed by the reacting molecules, and more product will be formed, because this is the endothermic reaction. It means that endothermic reactions are favorable at high temperature. Whatever we supply the heat for the reacting molecules, that heat becomes get absorbed by the reacting molecules, and they are converted to the products, because reaction is endothermic. So the forward reaction is endothermic. This is endothermic reaction, not exothermic, and is accompanied by decrease in volume. The forward reaction, it is accompanied by decrease in volume. Two molecules of ammonia are formed. If the temperature is raised, the yield of the ammonia decreases, and the proportion of nitrogen and hydrogen molecule in the equilibrium mixture increases. Means reverse reaction will be takes place here. Okay, so for the endothermic reaction, we have to increase the temperature of the system. Okay, so this is for the production of ammonia gas by the Haber's process, which is the endothermic reaction. You can see here the same reaction. What is the effect of the pressure? Change in the pressure. So in this slide, I would like to explain this now. The reaction between nitrogen and hydrogen gas produces two ammonia molecules. So four molecules of gas on the reactant side, 1 and plus 3. One nitrogen molecule, 3 hydrogen molecules. Right side, 2 ammonia molecules, 2 moles of gas on the product side. It means that fewer gaseous molecules, more gaseous molecules are here. Position of equilibrium shifts to side with fewer number of gaseous molecules, results in results in increase in pressure, not decrease. Results in increase in pressure. As we increase the pressure here, so if we increase the pressure, volume get reduces. So it is converted to the product which is formed. It is having the less number of product molecules. Now, position of equilibrium shifts towards the side with greater number of gaseous molecules, results in decrease in pressure. As we decrease the pressure, more number of the reactant molecules get formed here. The reaction will be favorable at left side, means this side, as we decrease the pressure. And as we increase the pressure, the more number of the product molecules get formed. So this is about the change in the pressure. So let us see what is the effect of the pressure change onto the another reaction. So in this reaction, increase in pressure shifts the equilibrium. In this reaction, increase in pressure shifts the equilibrium in the direction of lesser volume. So see here, only 2 moles, these are 3 moles. So lesser volume, or in the direction of lesser number of gaseous molecules. Okay. So the equilibrium in the reaction will shift in the forward direction. Increase in pressure. This reaction is favorable at increase in pressure. Increase in pressure. Okay. Then we will get less number of the product molecules. Okay. Means volume will be decreases here. So we have to increase the pressure to decrease the volume. Then this product will be formed, which has less number of the product molecules. Okay. So in this case, now another reaction. Dinitrogen tetroxide get converted to molecules. Reactant molecule will be 1, product molecule will be 2. So we'll shift in the backward direction. If we increase the pressure here, so that pressure will be applicable onto the product molecule, shifted to the backward direction here. Okay. On increasing the pressure means this reaction is favorable at for left side. More reactant molecules get formed here, and in this case more product molecules get formed here as we increase the pressure. Okay. So when the pressure on the system in the equilibrium is decreased, the equilibrium will be shifts in the direction of greater volume. When the pressure on the system in the equilibrium is decreased, if we decrease the pressure, the equilibrium shift in the direction of the greater volume. See here, if we decrease the pressure, the more reactant molecules get formed here, and if we increase the pressure, more product molecules will be formed here. So when the pressure on the system in equilibrium is decreased, the equilibrium shifts in the direction of the greater volume, or in the direction of greater number of molecules. Means in this case, in the case of the reactant molecules, if the same number of gas molecules appears on the both sides of the equation, a change of pressure has no effect. Suppose that product molecules and reactant molecules are same, then there is a no effect of the pressure. Okay. So if the product molecules are less as compared to the reactant molecules, increase in pressure will be favorable. And when the product molecules are greater as compared to the reactant molecules, decrease in pressure will be favorable here. Okay. So this is about the effect of the pressure change. Let us see now the effect of volume change. Now we know that since the pressure is inversely related to the volume, as we increase the pressure, volume will be going to be decreases. Let us show this. Pressure will be inversely proportional to the volume. Pressure will be inversely proportional to the volume. It means that as we increase the pressure, volume will be decreases. Okay. So see here, since the pressure is inversely related to the volume, the effect of change of volume will be the reverse of the change in pressure. See here, this reaction, the equilibrium will shift in the backward direction on increasing the volume. On increasing the volume means pressure will be decreases here. On increasing the volume, because volume of the reactant will be greater as compared to the volume of the product. Only one product molecule is here, and here, sorry, 2 product molecules are here only, and here 3 reactant molecules. This 2, this 1. Okay, so the equilibrium will shift in the backward direction here on increasing the volume, because volume of the reactant molecule will be greater. Where in this reaction, you can see the equilibrium will shift in the forward direction on increasing the volume. On because we increase the volume here by decreasing the pressure, the reaction will be favorable in the forward direction here, and it will be favorable in the reverse direction here. So this is the effect of the volume change. So it means that as we increase the pressure, volume will be decreases. So decrease in volume will be favorable to this here forward reaction. Okay, and uh, increase in volume, that means decrease in pressure, will favorable to the reverse reaction. So this is the effect of the volume change onto the equilibrium shifted equilibrium reaction. Okay, so in this way, by taking the example, we have explained this. Then the next effect of concentration change. Increase in concentration of any of the reactant shifts the equilibrium in forward reaction. Okay, as we increase the concentration of the reactant, more and more product will be formed. It is expected. This is applicable for any reaction. As we increase the concentration of the reactant, expected that more product will be formed. So the reaction will be shifted in the forward direction. Okay. Okay. So whereas increase in concentration of the products will be shift the equilibrium in backward direction. As the concentration of the product will be increases, then the backward reaction will be takes place there. Okay, so this is the effect of the concentration change. Increase in concentration of any of the reactant shifts the equilibrium in forward direction. Okay, then effect of catalyst. Catalyst is an inert substance that does not take part in the reaction. Hence, catalyst has no effect on the equilibrium position. Let us discuss now the application of Le Chatelier's principle. Application of Le Chatelier's principle. So see, the first application, it is increase of temperature. Now type of the reaction, endothermic. Endothermic reaction. Suppose that let us write here the reaction between the reactant A and B gives the product C and D. These products are formed here. Increase of temperature. Okay, so effect on change on the composition of the equilibrium mixture. What is the effect of the change here? As we increase the temperature, what is the effect is there? More products are formed because reaction is endothermic. Whatever we supply the temperature to the reactant molecules, the reaction is endothermic, means heat energy is absorbed and more product get formed. More and more product get formed here. So more products are formed, that is forward reaction is favored. So this reaction is favored here. And on the same time, the equilibrium constant will be increases. How the equilibrium constant will be increases? Because as the concentration of the product will be increases, of course, the equilibrium constant will be increases. The equilibrium constant Kc, it is equal to concentration of the product C multiplied by concentration of the product D divided by concentration of the reactant A into concentration of the reactant B. So if the more products are formed, then equilibrium constant is also increases, means numerator it is higher than the denominator. See now, increase of temperature onto the exothermic reaction. We know that exothermic reactions are actually favorable at the low temperature. So in this case, more reactants are formed. More reactants are formed here. That is backward reaction is favorable. If we increase the temperature in case of the exothermic reaction, actually in the exothermic reaction heat energy is given out. As we increase the temperature, more and more heat energy is liberated. So that product molecules get further react. That heat energy can be bring the reaction between the product molecules, and they are converted once again into the reactant molecules. So backward reaction is favorable there. So concentration of the reactant molecules will be increases in this case, means this denominator will be increases as compared to the numerator. So equilibrium constant will be decreases here. So this is the application of the Le Chatelier's principle, where we increase the temperature for endothermic reaction and for exothermic reaction, then decrease in temperature. In case of the endothermic reaction, what happens? As we decrease the temperature, the backward reaction will be takes place. Backward reaction will be takes place. Okay, see here. And in case of the exothermic reaction, decrease in temperature, forward reaction will be takes place, because exothermic reactions are favorable at low temperature. So already heat energy is liberated. So we cannot increase the temperature. We have to decrease the temperature. Then forward reaction will be takes place, means more and more product will be formed here. And in this case, the equilibrium constant will be increases. So in case of the endothermic reaction, decrease in temperature where backward reaction is takes place. In case of the exothermic reaction, decrease in temperature where forward reaction is favored, means this reaction will be favored there. So this is about the increase in temperature, increase of temperature and decrease in temperature. Let us see what happens when we change the pressure. So increase of pressure. So as we increase the pressure here, number of gaseous molecules are goes on decreasing. Means product molecules will be less here, smaller. This will be larger. We have to increase the pressure. Then pressure increase means volume get decreases. So this forward reaction is favorable. Okay. This is smaller volume and this is larger volume. For example, the reaction between nitrogen gas and hydrogen gas, the reactant molecules are larger in number as compared to the product molecules. So we have to increase the pressure here. Then and then the reactant molecules come closer to each other. Okay, and they are giving the product molecules. So this forward reaction is favorable. Then number of gaseous molecules increasing. Okay, number of gaseous molecules increasing. Suppose that this will be increased. For example, decomposition of dinitrogen tetroxide gives this nitrogen dioxide gas. So these are two molecules. This is one molecule here. So number of gaseous molecules are increasing here. Reactant molecules is 1, product molecules are 2. Okay, reactant molecule is 1, product molecule is 2. So increase of pressure, number of gaseous molecules increasing here. Okay, so this is the larger volume, this is the smaller volume. Okay, but in this case, backward reaction is favored, because we cannot increase the pressure here. As we increase the pressure, what happens? That pressure will be applicable onto this product, and there is a reduction in the volume of the product. It is back to converted to the reactant. So we cannot increase the pressure here. Remember this. Okay, we have to keep the pressure as low as possible. Then and then this forward reaction will be favorable. But in this case, as we increase the pressure, the backward reaction is favorable. Okay, so decrease of pressure, number of gaseous molecules increasing. See now in this case, as we decrease the pressure, what happens? As we decrease the pressure, what happens? Number of gaseous molecule increasing, means this is 1, this is 3. It means that the reaction is favorable at the left side. Okay, backward reaction is favorable. Backward reaction is favorable by decrease of pressure. So in such a reaction, actually we have to increase the pressure, because more product molecules should be formed. But actually, if we decrease the pressure, not increasing the pressure, what happens? The reactant molecules back to form. Okay, so this is about decrease of pressure. So in this way, there is an effect of the pressure onto the equilibrium system. So whenever the product molecules are less and reactant molecules are larger, so we have to increase the pressure here. Okay, then the reactant molecules come close to each other, volume get reduces, and the reaction will be takes place. Forward reaction is favorable. Okay, so this is about the increase of pressure or decrease of pressure or effect of pressure onto the equilibrium, where the reaction will be favorable onto the forward direction or onto the backward direction here. Okay, so this is the application of the Le Chatelier's principle. Let us take some exercise here to explain once again the Le Chatelier's principle. According to Le Chatelier's principle, predict the ideal condition for increasing the amount of product in the following equilibrium. Let us see here. See, according to Le Chatelier's principle, predict the ideal condition for increasing the amount of the product. So we have to increase the amount of the product here. Now in this case, delta H is negative, means it is exothermic reaction. When delta H means enthalpy change is negative, the reaction is called as exothermic reaction. Okay, heat energy is liberated here. For the reaction, delta is negative, delta H is negative, the reaction is exothermic, shifts in the equilibrium in the forward direction at high pressure. You can see here, we have to keep the pressure high, 2 plus 1, 3. The reactant molecules are greater number, product molecules are lesser number, volume will be less here, volume will be greater here. So we can apply the pressure here. Higher pressure reduces the volume, and the product molecule which is formed, it is having the lesser volume here. Less number of the molecules, product molecules are formed here. So for the reaction, delta H is negative, the reaction is exothermic, shift the equilibrium in forward direction at high pressure and low temperature. Because this is exothermic reaction, already heat energy is given out, so we cannot increase the temperature here. We have to keep the temperature as low as possible. As low as possible. For such reaction, we cannot increase the temperature here, not at all, because this reaction is exothermic, already heat energy is given out. So we can increase the temperature of the reaction. How we can increase the temperature of the reaction? You can take a very simple example. Suppose that we are dissolving sodium hydroxide in water. Sodium hydroxide in water. So if you take a water in a beaker and you are adding the sodium hydroxide pellets, what happens? The heat energy is given out to the surrounding when we are going to dissolve. Okay, heat energy is given out to the surrounding. The beakers becomes hot. So it means that the process is exothermic. Dissolution of sodium hydroxide is exothermic. So in such condition, we cannot increase the temperature. Okay, because already heat energy is liberated, heat energy is given out, the beaker becomes hot. So we cannot increase the temperature here. So we have to keep the temperature as low as possible. So when we are dissolving the sodium hydroxide in water, we have to keep the beaker in water bath. Instead of providing the heat to this, we have to keep the beaker in water bath. Okay, then we have to dissolve the sodium hydroxide in water. So try to understand about this. You can see now this reaction, conversion of two ammonia molecules into nitrogen molecule and hydrogen molecule. Delta H is positive here, reverse reaction. Means endothermic reaction. This is endothermic reaction. Since the reaction is endothermic, delta H is positive, hence ideal condition will be low pressure and high temperature. Low pressure and high temperature. In this case, low pressure and high temperature, excess of NH3 and removal of nitrogen or hydrogen. So this is about the prediction of the some chemical reactions where we have to increase the pressure, where we have to decrease the pressure. It will depends upon whether the reaction is exothermic, whether the reaction is endothermic. For exothermic reaction, we have to keep the temperature as low as possible. For endothermic reaction, we can increase the temperature, because in case of the endothermic reaction, already heat energy is absorbed. So we can supply the temperature to the system. And in case of the effect of the pressure or pressure change, if the reactant molecules are greater in number, we can increase the pressure. If the reactant molecules are lesser in number, then we have to decrease the pressure. So we have to see what type of the reaction is there, then we can change the temperature and pressure of the system. So this is about the application of Le Chatelier's principle. Application of Le Chatelier's principle. Thus, in this lecture, we have completed the Lee Chatelier's principle with more and more examples.